an advertisement for the December Coregonid webinar. We're really excited to have Carl Schreck. Carl is from Oregon State University, and he and David Noakes really helped found the Oregon Hatchery Research Center. And this is a center that has really manifested a vision to sort of produce fish in an artificial setting that are as most like their wild counterparts as possible. So it'll be a talk about salmonids. Of course, coregonids are in the family Salmonidae, but with potential application to some of the things that we may are trying to do at our Tunison USGS field station over the next several years. So this is going to be a really exciting seminar. And Carl is a world famous physiologist, fish physiologist. He is retired, but still super active, and I know he's going to give a great webinar. So please sign up for that. And we hope to have a really good turnout for Carl's webinar just about a month from today. And so today I'm really honored to introduce my friend Dan Yule. Dan is a colleague at USGS. He was born and raised in central Wisconsin and is now working a little bit northern Wisconsin in Ashland, where he joined the Great Lakes Science Center in 2004. His academic career was at the University of Wisconsin at River Falls, where he got a BS in 1989. He then went out to Utah State to work with Chris Lukey, and where he got his master's in 1992. Dan is currently the interim station chief, sharing duties with Dr. Mark Vinson. And Dan sees himself as in his words, which is great, a Swiss Army researcher, Swiss Army knife researcher. Got the knife part in there. Yeah. He works on several things, including Lake Superior fish status and trends, which is used, of course, by the Lake Superior managers, evaluating high-tech acoustic samplers to reduce bias in fisheries acoustic surveys, advancing Lake Superior ecological studies, and, of course, science to inform conservation and restoration of native ciscos in the Great Lakes Basin. And I think he's going to touch on all those topics today in this really excellent talk. I had a chance to see the talk at the Coregonid Symposium, which was in September in Evian, France. Dan was one of the keynote speakers. He was dressed a little bit differently for that keynote than he is today. He did not have on a hoodie and a hat. And we are a very casual, relaxed webinar, so it's totally fine. But just if you can imagine Dan in a bow tie, that's what he was wearing in France. But he did speak English for the talk. So Dan, we look forward to your talk. I don't know if Renee has your slide deck up there.
I'll share now.
Oh, you're perfect.
Yeah.
All right.
I'm not a bot, but I am going to take myself off video because I find it distracting.
Okay. And we hope that you'll stay on for questions after Dan's talk, which is about 45 minutes or so.
How did I do?
Okay.
Can you see it?
We see it. Yep.
Perfect. Yeah, thank you both for that kind introduction. And I would like to say hello to everyone. As you can see, the title of my talk today is When Good Planning Meets Opportunity, the story of the epic 2022 Coregonid year class in Lake Superior. I see this webinar as a great way to get some feedback on our ongoing science here at the station. So I hope my talk will generate some discussion and hopefully even some tough questions. This talk was given for an international audience, so I had to give a little background on Lake Superior. It's a very beautiful place. It's the largest of the Laurentian Great Lakes with a surface area of 82,100 kilometers squared. It's deep, averaging 147 meters, low elevation, only 180 meters above sea level. It's a northerly lake, so it will often freeze over, although not as frequently as it had in the not too distant past. It's ultra-oligotrophic with a total phosphorus level of only 2.3 micrograms per liter. So the fish I'll be discussing today live in a big, deep, cold, and sterile lake. Lake Superior is home to at least 4 species of ciscos with the status of 2 currently uncertain. Of these populations, the 3 shown at the top of the slide in the red box, cisco, bloater, and kaya are considered strong. Cisco is a pelagic species and is largely zooplanktivorous. Cisco support the largest commercial fishery on Lake Superior, with fish harvested during November for their roe. And it was actually interesting. This was the first year, to my knowledge, that cisco yield exceeded lake whitefish back in 2022. The fisheries for the other ciscos are comparatively small. Kaya is a deep water species that feeds on mysis. The bloater resides in the deep hypolimnetic habitat and relies on both the pelagic and the benthic pathways. At the Coregonid Symposium, my colleague Owen Gorman provided some new and I think rather compelling evidence that moves the status of short-nosed cisco in Lake Superior from uncertain to present, or some of the speakers called it rediscovered at the time. Blackfin ciscos and short-jaw ciscos shown at the bottom were once highly abundant around 100 years ago, but now are extremely rare, so their status is currently listed as uncertain. The understanding of the relative abundance of ciscos around the 1920s in the work of Kelps was based on bottom set gillnets. And so one thing that Owen is working on is to resume gillnets sampling, which should shed some light on the contemporary relative abundance of these uncertain forms, especially if enough verifiable specimens can be obtained, we may be able to advance our GT sequencing panel on Lake Superior, which I'll be discussing a little bit later today. We sample ciscos with 2 major surveys annually. First, we conduct during May and June our nearshore bottom trawl survey. That's shown with the green dots around the perimeter of the lake. This time series dates back to 1978. This survey provides information on adult bloater and also serves as an index of recruitment of bloater and cisco based on the catches of age 1 fish. We follow this up with a July offshore bottom trawl survey, which are the sites shown with the pink circles in the top map. This offshore survey began in 2011. This survey is used to track Kaya and Kaya recruits. Every 5 years, we get funding to collect what is called the Coordinated Science and Monitoring Initiative lake-wide fish surveys. This design is depth stratified and spatially balanced, and we've repeated it now 3 cycles, 2011, 2016, and 2022. During the CSMI years, we actually conduct 2 lake-wide surveys. The first one is in July, where we visit all 56 sites and sample with bottom trawling. And then we follow this up with a nighttime survey, usually around August to early October, where we sample pelagic fish with fish acoustic methods, and also we use midwater trawling to ground truth the acoustic data. This survey has provided lake-wide abundance estimates of cisco, bloater, and kaya. And finally, during 2014, we added larval collections to all these major surveys. So essentially, whenever we trawl now, we're also doing a Newston surface tow simultaneously. I began working on Lake Superior as a younger man in 2004, and over those nearly 20 years, it has been my displeasure to report declines in the cisco community. The plot on the right is our index of recruitment of cisco. Plot on the left is our index of cisco recruitment based on the nearshore bottom trawl survey. There had been strong recruitment events measured in 2004, which was my first year on the lake, when we caught the 2000 year classes, age 1. But since that time, recruitment has been dismal. The plot to the right shows total spawner abundance of bloater in red, kaya in pink, and cisco in blue as measured by the CSMI cycles I just mentioned. Unfortunately, poor recruitment has led to big declines in the abundance of all 3 major species in Lake Superior over time. Bloater abundance in particular has gotten rather low. Another thing to understand is that the dynamics of ciscos in Lake Superior are driven as strong recruitment events separated by gaps of dismal recruitment. As strong year classes age, they grow and move through linked frequency plots like waves. The recruitment of the major species is synchronized. You can see that synchrony with our bloater data shown in the left-hand panel and our cisco data in the right-hand panel. So basically, when cisco recruit well, so do bloater and kaya, and vice versa. As recruitment has been poor, concerns over the sustainability of these fisheries that the Cisco support have grown. We've seen headlines like scientists concerned about Lake Superior's declining Cisco population and Europe's taste for caviar is putting pressure on a Great Lakes fish. We've spent a lot of time at our Lake Technical Committee meetings discussing these dismal trends, and managers have debated safe harvest levels. In response, most jurisdictions have lowered commercial catch quotas, especially for Cisco or Coregonid artidae, but no fisheries have been outright closed. As Cisco's declined, we conducted research to try to better understand their respective life histories to try and determine when critical bottlenecks to survival may be occurring. So I'm framing this up about what we knew around 2019. In general, around 2019, I would say we knew the most about adults, including estimates of their abundance, the habitats they used, and the timing of their spawning, and even their growth trajectories. There's even a lot of information out there about the fecundity of the different Cisco species. I'd say we knew far less about the egg stage, except we did recently acquire knowledge of where Cisco eggs seem to overwinter. We also thought there was sufficient survival of eggs because we had documented billions of larvae hatching each year. Larvae has been a tough life stage for us to study because larvae of the different species are morphologically cryptic. We knew surface waters was critical habitat for this life stage, and we also knew that billions of larvae typically died each year, but the reasons why were elusive. We knew next to nothing about age 0 fish after metamorphosis. We could not identify species, and they had been extremely rare and difficult for us to find. We did know a fair amount about the age 1 because they were vulnerable to our bottom trawl weirs, so we knew their abundances, at least relative abundances, their spatial distributions, and how they grew. To be honest, around 2019, we had some life history knowledge, but with huge gaps, especially for the larval and the age 0 life stages, because we could simply not identify the species reliably because of them being morphologically cryptic. As numbers of Cisco's declined, there was increased scrutiny on our survey methods, especially as managers have had to make tough decisions on how to set quotas for commercial fisheries. In a recent study led by Peter Urista, we used some CSMI data from 2005 and 2011 on algae, zooplankton, large predatory zooplankton, and pelagic fish to model the biomass spectrum of the Lake Superior pelagic food web. For those of you unfamiliar, the x-axis is a log scale of organism size, and the y-axis is average lake-wide biomass, again shown on a log scale. I want to focus in on the pelagic fish dome shown in the red box. Here we predicted the shape and position of the pelagic fish dome shown with the red dashed line based on the shape and position of the lower trophic levels that support them. The observed pelagic fish data shown with the black circles are based on the lake-wide acoustic surveys. We can see that the observed dome is well below the expected biomass dome. This could be a predatory effect as lake char have been restored in Lake Superior, but we suspected there were other explanations. One thought we had was that our fish biomass estimates derived from the ship-based downlooking surveys were biased low because the volume of water we sampled near the surface is trivial. Also, we could not rule out the possibility that vessel noise may be causing avoidance behavior. Again, most likely in surface waters, leading to a downward bias in our fish biomass estimates. So I would say around 2019, there were several impediments for acquiring new knowledge of Cisco's. First, we had no way of identifying eggs, larvae, and age 0s to species. Second, our pelagic fish surveys were not likely measuring true abundance because of problems in the surface waters. Third, these knowledge gaps made understanding of the bottlenecks really difficult. So finally, the information we were providing the Lake Superior fish managers was simply not good enough, and we had to do better. We needed to improve. One thing I've come to appreciate during my career is that concerns can lead to extra funding. In recent years, funding for the Great Lakes coregonid research has increased significantly. One development has been the increased funding for coregonid conservation and restoration science through the Great Lakes Restoration Initiative administered by the US EPA. Roughly $7 million have been spent since 2017 to support science planning, operational support, and monitoring of ongoing restoration. A second major event was passage of the Great Lakes Fisheries Research Act of 2019. This bill increased base funding of the Great Lakes Science Center from about $8 million to $15 million annually. This extra funding is being used to conduct studies of new technologies to improve our pelagic fish surveys. And it's also led to the addition of new scientists that focus their portfolios on coregonid conservation and restoration. It's been a really exciting time to be working at the Great Lakes Science Center, and we're really grateful for all the support that we receive from partners to help us secure this extra funding through Congress. The new funding has allowed our center to acquire a next generation sequencer and to hire Dr. Amanda Ackus, who is an expert at processing the data the sequencer provides. So suddenly, we now have the ability to use genotyping in thousands by sequencing, which harnesses variation in single nucleotide polymorphisms across species, thus greatly improving species assignments over the past genetic methods that were equivocal at best. Moreover, Amanda and her lab has done a remarkable job building a workflow pipeline and the associated databases to track samples. The Great Lakes Science Center now has capacity to identify rare forms like the short-nosed cisco I mentioned earlier, plus eggs, larvae, and juveniles of the common forms to species with high certainty at relatively low cost. I think this development represents a real game changer in the acquisition of especially early life history knowledge. So things were looking rosy in 2019 when all of a sudden we were dealt the stress of the COVID pandemic. Little field work got done in 2020. Couldn't use Canada ports in 2020 and 21, so there were huge problems. Also with the global supply chain, we had sent our ship out for haul out. We thought it would be back in 4 months, and it took over a year because of the supply chain issues. So we had planned to do the CSMI survey in 2021, but we had to table those until 2022, and we were distraught here at the station. But you know, we felt like we were not going to be able to meet our partner needs by not being able to deliver the survey in 2021. But I'll say this, sometimes when times are tough and you feel you're having the worst possible luck known to man, things may be turning around for you without your knowledge. So during the pandemic, we planned on how we would utilize the new funding to learn if high-tech acoustic samplers could improve our pelagic fish surveys. We decided to evaluate 2 new platforms beyond our traditional approach of ship-based downlooking surveys. We developed contracts to bring in sail drone. Shale drone are environmentally friendly as they're powered by wind and solar. And a platform like the vessels has downlooking capabilities, carrying a scientific-grade echosonder. We also coordinated with the Monterey Bay Aquatic Research Institute to bring to Lake Superior their autonomous underwater vehicle, or AUV, called the Triton. This unit, powered by battery, has both up and down looking capabilities. We developed 3 objectives. First, we decided we would use overtakes of the quiet sail drone platform to explore if vessel avoidance is occurring. Second, we decided to use all 3 platforms on the same set of transects to learn if these robots could provide us better data. And finally, we wanted to document day and night behavior of pelagic fish, especially in surface waters, with an uplooking sea spider. Please remind me or reach out to me if you have any more questions about these high-tech acoustic samplers, because I really don't have much time today to get in depth about them. But the principal advantage of sail drone and the AUV Triton is that they have much lower noise levels, which greatly increases the range at which small fish can be discerned from background noise. Normally, our smallest targets of fish of interest is about minus 60 decibels, which is equivalent to about a 2.5 centimeter fish. And given the noise levels of the RV Kai when she's underway, we can detect a fish of this acoustic size down to about 75 meters. Because the robot platforms are quieter, a 2.5 centimeter fish can be detected to a range of 120 meters with the sail drone platform and down to 160 meters with the AUV Triton. So this type of improvement in signal to noise ratios represents another likely game changer, especially if these robots do not invoke fish avoidance behavior. So I'll move now onto the results. First, I'll share what traditional surveys provided us during 2022. First data I'll share is the abundance estimates of larval cisco. Data collected in May are at the top, June in the middle panel, and July at the bottom. The y-axes are larval abundance, and know the different panels have different scales. We have no data during the pandemic years. Since 2014, when larval sampling began, we did see some low-level recruitment of the 2014 and 2018 year classes, which are shown with the black boxes. The rest of the years have been essentially zero recruitment. One thing we have come to understand is that when the winter and spring temperatures are cold, May catches tend to be low and vice versa. We now see low May catches as a good signal because we think it points to delayed hatching of our ciscos. I know this is counterintuitive, but again, the data are becoming more and more clear that low catches in May is not necessarily a bad signal. June catches in the middle panel, again, seem unrelated to recruitment, at least to the 2014 and 2018 year classes here. They're up and down, and it doesn't seem to matter. In 2022, we had low May catches and moderate June catches, but July catches were 2 times higher than anything we had seen. One thing I want to point out is these plots are a mixture of multiple species, and sites are only visited once per year. So we're looking at, not individual species data here, but a composite of all of the larval ciscos that were caught. My colleague Mark Vincent has been working on an analysis to explain drivers of recruitment of ciscos, and he'll be rolling out some of those results this winter. But based on the 2022 larval results, we now believe that the critical bottleneck to larval survival occurred during June and July, and that larval ciscos in Lake Superior survive best when average surface temperatures during June are cold or less than 5 degrees Celsius. When we plotted the growth trajectories, the 22 larval cohort was slightly above average. One thing of interest is that rapid larval growth has not been a good predictor of recruitment levels. We had some recruitment in 2014 and 2018, and in those years, the larvae ended up being on the small side during July. The 22 cohort was not the fastest growing cohort, but close to it. Again, our inferences here are being hampered by our inability to identify the larvae to species. When we conducted the CSMI pelagic fish survey in late summer 2022, we started on the western end of the lake in mid-August and moved eastward, finishing up in early October on the eastern side. The sizes of the circles in this map reflect the ship-based acoustic densities estimates of age zeros. Densities of age 0 were low in the western half, as were our midwater trawl catches. It was only about halfway through the survey at a site just north of Isle Royale that we sampled in early September that it really occurred to us that we may be documenting something rather amazing. Here's a picture of that first big catch, and that may not look special to you, but consider that in this single trawl sample, we caught more age zeros than we did in the 2011 and 2016 CSMI surveys combined, which had over 140 trawl samples of effort. So as we moved east, densities of age zeros increased, and I think this pattern was driven in part by the fish growing and becoming more vulnerable to our midwater trawl gear. And moreover, they began to occupy greater water column depths as the heat of summer progressed, thus becoming more vulnerable to our acoustic sampling. Never seen anything close to what we measured in terms of acoustic densities in 2022. This is an example echogram from an offshore site. It shows the upper 100 meters of the water column, but you can see very high numbers of small acoustic targets in the uppermost 30 meters, but few present below that depth. I know this was by no means a cherry pick of an echogram, as we saw similar densities at a wide range of sites. We shattered the record of age 0 cisco catches, which is shown in the purple coloring in the bottom panel linked frequency distribution. It just shattered anything we had seen compared to the 2011 and 2016 CSMI lake-wide midwater trawl surveys, which is in the data in the top 2 panels above it. When we compared mean daily catches of larvae in surface trawls shown in blue with the age 0 densities from the acoustic and midwater trawl survey results, which are shown in red, it was clear that there was something special about how well the larvae had survived through metamorphosis. Larval densities were about 1,000 fish per hectare in the surface waters, while age 0 densities were about 250 per hectare lake-wide. We continued to do larval tows throughout the late summer of 2022, and this was the first time we had done this, but late summer catches of larvae, shown with the blue dots in September and October in the surface waters, were trivial. When we scaled up the stratum estimates from the acoustic survey of age zero abundance to the estimated surface areas of 4 bathymetric strata here, we learned that the abundance in the less than 30 meter stratum was low. The abundance in the 30 to 100 meter stratum was moderate, but the total abundances in that 100 to 200 and greater than 200 meter strata were amazing, almost a billion fish in each stratum. The total lake-wide estimate was an astounding 2.1 billion fish. And we had long assumed that the nearshore zone would be critical habitat to age zero fish, because cisco and bloater are thought to be nearshore spawners. But it turns out that the epilimnion of the deep offshore waters, where bathymetric depths are greater than 100 meters, is truly the critical habitat for age zero ciscos in Lake Superior. Again, made possible, this new knowledge, by this large recruitment event coinciding with our sampling. Here we've combined the sizes of larvae and age zero caught during 2022 into one plot. The data on the left are the surface larval tows, and the data on the right are the midwater trawl catches. Again, all species are combined here because we haven't applied any genetic results yet. But the mean sizes of each day are graduated by surface temperature, with purple being cold surface temperatures, less than 8 degrees Celsius, and yellow and orange and red being warmer surface temperatures. What is evident is that Lake Superior had been remarkably cold through the end of July 2022. Surface waters began to warm rapidly in early August. And then, size selectivity of our midwater trawl gear aside, these data do suggest that cisco grew at remarkable rates during that 3-week window from the end of July to mid-August 2022. Here we compare our 2022 lake-wide abundance estimates of pelagic fish to the 2011 and 2016 surveys. During the 2011 and 2016 surveys, rainbow smelt, shown in orange, had been the most abundant species lake-wide. With the banner number of age zeros present in 2022, the combined abundance of ciscos, here shown with the black box, exceeded that of rainbow smelt. And this is truly, I think, a significant event, because one may have to go back as far as maybe 70 years to find a time when the combined abundance of ciscos exceeded rainbow smelt in Lake Superior. So that was the extent of what our traditional surveys were able to provide us. And over the next few slides, I'll now share some exciting inferences that were made possible by the newly developed genetic techniques. The remainder of the data that I'll share is provisional and has not been vetted by the U.S. Geological Survey's fundamental science practices, at least not all of it, especially the genetic data, but we're working towards that end with a couple of publications that we hope to get out this winter. Center's Genetics Lab, I think, has done a really remarkable job of processing over 11,000 larvae collected in 2022. The blue slices of these pies shows the occurrence of cisco. And note that cisco were predominant in our nearshore samples around the perimeter of the lake. But also note that cisco larvae can be found everywhere, including offshore. This was incredibly new insight, because we had long assumed cisco larvae would be confined to the coastal regions, because that is where we thought the spawning was occurring. The green slices show the occurrence of kai. And I want to point your attention to the south shore east of the Keweenaw Peninsula. There's a lot of green there. And so we think this is a signal that the eastern half of the lake is probably a very important spawning grounds for kai. Bloater larvae in red were really rare, at least when we sampled larvae. In fact, bloater larvae only represented about 1% of the larvae we collected in 2022. When we compared larval occurrence to adult occurrence, bloater adults represented 6% and their larvae 1%, cisco adults 21% and their larvae 71%, and kai represented 72% of the adults and 19% of the larvae. We think this disproportionate amount of cisco larvae is driven in part by the higher fecundity of cisco compared to the 2 deepwater cisco species. They're larger bodied, and an adult female cisco will carry up to 22,000 eggs, compared to about 5,000 for an adult bloater female and 2,000 for an adult Kii female. So having more larval cisco than bloater and Kii is likely caused, at least we believe, by the higher fecundity of cisco. Here we plotted the sizes and larvae in age 0 by species against collection dates. So now we're applying here the results of the genetic identifications. The bloater data is at the top, cisco are in the middle, and Kii are at the bottom. Note that the catches of bloater larvae during May and June had been trivial. That's the top panel, while we caught high numbers of both cisco and Kii during that time frame in the middle and the bottom panel. So another explanation for the low overall occurrence of bloater larvae may be that most larval bloater emerged after the bulk of our larval sampling had occurred in 2022. A total of 1,800 age 0 cisco we caught in late summer have been assigned to species by our genetics lab. And even at this very young age, the species are taking on a distribution more like one would expect based on our studies of adult distributions over time. By late summer, cisco, again shown in blue, and bloater, shown in red, were predominant at the shallower depths we sampled around the perimeter of the lake, while age 0 Kii had become predominant offshore. So remember, cisco had been the most abundant as larvae offshore during July, but by late summer, they had been replaced by Kii. So it didn't take long for this to occur. This suggests that either cisco larvae vacated the offshore zone by late summer or they died disproportionately. And I think that I am sort of more in favor of the vacate hypothesis, and I'll explain that later. When we looked at the occurrences of age 0, compared to the adults and larvae, we saw a dramatic shift by late summer. The occurrence of cisco age 0 to the total dropped dramatically, and there was a concurrent increase in the percentages of age 0 bloater and Kii. In fact, by late summer, the proportions of age 0 really closely matched the proportions of adults. Again, this insight would not have been made possible without the modern genetic tool. These data also allowed us to measure larval growth rates to the 3 common species for the first time. Remember, cisco in blue and Kii in green, they seemingly emerged first and bloater in red later. When we fit linear models to these data, we saw that the daily growth of cisco and Kii that hatched first were similar at about 0.5 millimeters per day. Bloater growth was measured at 0.63 millimeters per day, so faster. And although they seemingly hatched last, by late summer, the bloater had caught up with Kii with respect to size. When we collected age 0, we sometimes encountered these bimodal distributions like I've shown in the photo. We now know that this bimodality is driven by differences in sizes of age 0, with the largest age 0 being cisco, and the smaller age 0 being a mix of Kii and bloater. We were struck by the wide range of sites of each species on each sampling and date. This could be explained by individual growth variation, but more likely it is a signal that hatching of each species is prolonged and could take several weeks. When we went out this spring to index recruitment based on age 1 catches, we were amazed. At many stations, we had to use the crane to empty the bottom trawl cod end. At one site, we caught 5 totes of age 1s with an estimated catch of over 24,000 individuals. We often had tables of age 1s to contend with the process. And now that these fish have survived their first winter, we are confident that the 2022 cohort is going to be around for the foreseeable future. When we compared our spring 2023 catches to the rest of the years in our time series, you can see that the 2022 cohort at the far right was record-breaking for bloater in the top panel, cisco in the middle panel, and Kii in the bottom panel. 2022 was just a remarkable year for recruitment in Lake Superior. Please note that the y-axes are different in each panel, and also that our time series for Kii recruitment is shorter because the offshore crews that we use to index them only began in 2011. We've not yet sent out our age 1 samples for genetic assignments, so know that the map here is based on occurrence, is based on our field identification still. But what we saw is the contribution of cisco in our nearshore survey was 88% cisco, 11% bloater, and only 1% Kii. that was a little surprising to have so many Cisco caught, but we believe we're pretty good at identifying age ones because, again, the Cisco are larger bodied. During our July 2023 survey, Kaya were 100% of the catch. This recruitment event was widespread over the entirety of this massive lake. No doubts, I think, represents the largest recruitment event of Cisco's documented by our Great Lakes, by our center on any of the Great Lakes in the last 40 plus years of standardized sampling. News got out fast, and finally, after nearly a decade of worrisome headlines, they flipped to lovely headlines like record lake herring population means Lake Superior anglers will catch bigger fish. And that's true. We've got some really nice, albeit anecdotal evidence that the salmonids are growing at remarkable rates this year. A couple of records have been set, I think, on Chinook salmon already. And another title was Cisco explosion in Lake Superior may be the largest on record. So as you can imagine, the Lake Superior fish managers let out a collective sigh of relief. And this level of recruitment means that concerns, at least most of the concerns for the common species, have been eliminated, at least for the foreseeable future. So it was really great when FUN finally gets some good luck and can report on some promising and happy results. I'm now going to move on to some new knowledge of behaviors of Cisco in Lake Superior that was gathered by the high-tech acoustic sampling effort. I'm going to start with uplooking sea spider results. The echogram shown on the left is a daytime echogram, and on the night is one that was collected at night at the same site. During the daytime, these targets shown on the left-hand side, we believe to be large Cisco because of their large acoustic size, and they were fawn schooling. But the schools were rather small, numbering in the tens and not in the hundreds of individuals. We know they were actively swimming because they did not spend long within the fixed aspect acoustic beam, so they were moving through the beam rather quickly. At night, the fish seemingly moved up a bit in the water column and were solitary. That is, the schools broke down, and we can infer that from their swimming speeds were much slower because of how long they remain in the acoustic beam. Now, if you want to know more about what was learned from this sampling with the sea spider in Lake Superior, I wanted to let everybody know that Ryan Grove's dissertation at Lakehead State, which was just finished here recently, is now publicly available. And so I wanted to say congratulations to the now Dr. Grove. The age of Cisco's, here now we're looking at age 0, showed a similar pattern in that they were found schooling in the epilimnion during daylight, but the schools had more individuals, likely numbering in the hundreds to thousands of individuals. Note that the fish were present in the upper 20 most meters of the water column during daylight, so in the epilimnion. At night, most age 0 were detected in the upper 10 most meters of the water column. That's your echogram to the right, where they were again solitary. The schools broke down. And they again were swimming very slowly based on the long time they spent in the acoustic beam. So we saw some deeper targets at night, which we suspect are adult bloater that had left the bottom after the sunset. So it seems age 0 school during daylight in the epilimnion, just like the adult Cisco's will, or Coregonid artidae. And so all this is new knowledge made possible by the deployments of this sea spider device in 2022. Here's an echogram that was collected by sail drone. Time is on the x-axis and water column depth is on the y-axis. The bold red band in the middle is the lake bed, and that's a strong reflector of sound waves. The data is being shown with a low mark threshold here that lets us see mysids and zooplankton scattering simultaneously. We see in deep water, just before it gets really dark, that mysids will appear to move off the bottom as shown with the number 1. We then see mysids ascend at night as shown with the number 2. There were 4 vessel overtakes of sail drone during the course of this night, and you can see those overtake events because what we're seeing is crosstalk from the ship echo sounder as it overtake the sail drone echo sounder, so you can see it on the echo sounder that the sail drone was carrying. You can see mysids present in the upper water column, maybe the top 50 meters or so, throughout the nighttime period. And as the sun begins to set, the mysids will move back to the lake trout, or the lake bed as shown with number 5. As the sail drone continued to sample during daylight, we can see two distinct layers of what we think are zooplankton, and those formed in the upper water column shown with the number 6. This is truly amazing data and shows, I think, how sail drone represents a powerful new lens for studying the Lake Superior ecosystem because of its much lower signal to noise ratios. Unlike our ship, a sail drone can also run 24 hours. This is an echogram that shows daylight, dusk, and night acoustic backscattering of fish only. Given the depth sampled, we are looking primarily at kai. Along this deep 200-meter bathymetric depth transect, we can see pelagic fish residing in the open water during night at water column depths between 50 and 100 meters, or 75 meters, shown with the number 1. At dawn, they made a descent down deeper in the water column, as shown with number 2 in the arrow, taking up residence in the open water at about 100 meters depth and below. They then spent daylight hours at these same depths, shown with the number 3. So not migrating fully to the lake bed was something we had kind of suspected may be occurring, because some of our day bottom trawl catches of kai do tend to decline over the deepest part of the lake. But we now have proof, based on this sampling during daylight, that our bottom trawl estimates of kai are likely conservative in the deepest parts of the lake, because not all kai are migrating to the lake bed. So this is exciting new knowledge, although it does point to a weakness in our offshore bottom trawl survey at these great depths. During August 2022, we ran transects in the Western Arm with the Monterey Bay Aquatic Research Institute, or what we call the Triton. We also ran transects, the same ones, with the RV Kai and the sail drone. So we have a nice comparative study to work on. This AUV has a range of about 500 kilometers per battery charge, and it is equipped with acoustic and environmental profiling payloads. The Triton has both up and down looking transducers with a couple of different operating frequencies. So it has 4 transducers in total. And all the transducers are on gimbals, so they will aim towards the surface and the lake bed during both ascents and descents of the Triton. The AUV will have to porpoise periodically to the surface to acquire satellites to stay on course. And during these porpoises, it acquires, I think, really valuable environmental profiling data. Otherwise, when not porpoising, it would fly horizontally. Now, Hannah Blair is the postdoc at Cornell that's working on the comparative data that I mentioned, and she plans to roll out some of those results at the winter Lake Superior Technical Committee meeting. So if you have a chance, you want to hear what was learned when we compared these 3 platforms, that would be your chance to get it. In this Triton echogram, the up and down looking channels have been combined into one echogram. The gaps are where the Triton travels up to the surface to get locations and talk to the satellites. The background noise, interesting, in the down-looking channels at great depths are higher compared to these porpoise events, are higher during these porpoise events, shown with number 1. At dusk, like with the sail drone data, we see evidence of mysids migrating up into the water column, as shown with the number 2 in the arrow here. And of course, once again, we can see the strong backscattering layer from mysids and surface waters at night, shown with the number 3. Then at dawn, as it approaches, the mysids layers can again be seen descending back to the lake bed. Probably the most exciting thing for me was being able to use the Triton to see some of these age 0 schools in surface waters. Here we have 2 Triton up-looking echograms only, showing schools of small fish between 5 and 10 meters of water column depth in the circles. And undoubtedly, these are the age 0 ciscos that we were catching later in the year. The ability to sample fish in near surface waters without disturbing the fish is a very exciting proposition. Know that these daytime schools went undetected by sail drone. And also the Kai crew was sleeping during the daylight, so we didn't sample them either. So I'll wrap up now with some take homes. First, I hold that the new funding is advancing knowledge of Lake Superior ciscos at an unprecedented rate, especially early life history. Second, I think the large recruitment event coupled with advances in GT sequence and the high-tech study could not have coalesced better. Life history knowledge of larvae and age 0 leap forward. And I've seen enough, I think, from the high-tech study to know that these new tools can improve our pelagic fish surveys moving forward. And it is my dream, it's not my decision, but it's my dream that Lake Superior will be the first to use robots for monitoring pelagic fish populations. I'm also excited by the possibility of simultaneously monitoring multiple trophic levels during these surveys. Finally, dismal headlines on Cisco's turned into lovely headlines. And also, we're really excited about this year class because we think it'll provide opportunities for further research for years to come. And one of the things that Mark and I are particularly interested in pursuing is, given the new climate, how likely are the 2022 thermal conditions that led to the event likely to be repeated in the future? This work would not have been done without a bunch of people. I'm just merely the good-looking front man. They're the wind behind my sails. And I don't have time to mention them all here, but I'm grateful for the work they did. And with that, I'll turn it over to questions.
Right. Thank you very much, Dan. Great job. A lot of information there, not only in terms of ecology and recruitment, but also in terms of technology that can help us take steps forward in our understanding in ecology and monitoring for restoration and conservation. So yes, you're getting some virtual applause there, people using their icons or whatever those are called. So we're now at our question time, as Dan indicated. So you could, the best thing is if you just flip your camera on, raise your hand to ask questions. You can also put them in the chat, and we'll sort of alternate between people giving questions like on camera versus the chat. I'll try to monitor those maybe with Renee and Dan's help. Let's see any questions yet. I'll start off with one. Maybe just the one that's most recent. So did I catch that the sail drone did not sample those A0 Ciscos in the top 10 meters? And is that just because of the narrowness of the cone or because of the noise, or we don't know yet?
Yeah, no, that's just something I learned from having in a recent meeting. We have these group meetings with Cornell as they're learning from the data that were collected. And that was a comment that was made by one of the postdocs because, we're seeing it in the Mabari Triton data clearly, these schools, but they're not being detected with the sail drone. And I think it is not an issue of noise disturbing them. I think it's the narrow beam issue. I think it's the same problem that we have with our ships and sampling fish in the very near surface waters.
Okay.
Yeah. And there would have been no reason, really, because we were moving rather slow, but there's something about just that narrow beam. That's what Tom Evans, the postdoc, said. So.
I can add something.
Yeah.
Something to that, Dan, and Bo. The transducer on the sail drone is down 2 meters on that long keel. So it's also deep compared to it's actually comparable depth to the ships. And that's probably the main reason that we can't see them.
Yeah, the beam is really small then at 5 meters.
Too. And then you have a near field area. So you go down 2 meters and then you have a near field that you don't trust the 2 meters next to following meters. So you're down 4 meters before you get data that you believe.
Thank you, Lars.
Okay. Tom.
Pratt. Hey, Dan. Yeah. You can hear me? Great talk like usual, Dan. I'm glad you were in charge. So when they put up a statue at the Kauffman Stadium or the Brewers play, it'll be of you for this final. So I think that's wonderful. My question is, though, you've hinted at what Mark is doing, and I don't want to steal any future stuff, but have you guys looked at the past temperature data to see if this was a crazy temperature anomaly? Or like, have there been years where you've had these really cold temperatures followed by rapid warming where we haven't seen year classes? Or Is this going to be the magic bullet? And if you don't want to answer now, if you want to wait, that's totally fine. But that's what I
No,
was-
I'll take a stab at it, because I recently had to summarize his recent work here at a CSMI series of CSMI workshop meetings. But yeah, the first thing we did is we did a CART model on the 45-year H1 recruitment time series. And the explanatory variables we looked at were, ice cover by month, surface temperatures, wind speeds, wind direction. So mostly environmental variables. And so we categorized the recruitment over the 45 years into high, which was greater than 50 per hectare, age one, sort of a measurable group, which was 3 to 50, and in a low group, which was no recruitment to 3 per hectare. And anyways, when we run that model, one of the things that pops is early ice cover in January, at least 15%, was important for all of the large or high recruitment years. And moreover, the second variable that popped was cold June temperatures, where it had to be below 5 degrees to be, to produce a really high year class. Now, when we looked at the thermal regime in 2022 to kind of the pre-El Nino or pre-1998 data that was available to us online, we saw that the 2022 temperature profile over the months of the calendar year was almost exactly what the average had been in the years from like 1981 to 1997. So when most of the prior strong recruitment events occurred in that time frame, temperature in 2022 is nearly identical. And so what's his name, Austin at the Large Lake Observatory, I was also interviewed about that this summer, and he said it was really an unusually cold year in 2022 because ice coverage was about normal. It got back to about 80% or 85%. And the spring had been so cold with a lot of overcast, rainy days, and also a lot of winds out of the northeast, as opposed to a southern wind, which can drive our climate warmer. Anyways, we think that was critical for the larvae of 2022 to survive, where they normally wink out and they disappear from us in our surveys. In 2022, they did not. So does that answer your question, Tom?
Yeah. No, thanks. I look forward to the full analysis when I get to see it. Can I squeeze one more quick one in, Bo, or do you want to get up to the online questions?
No, go ahead. Yeah, we have time.
Okay. So Dan, this one's probably a little more speculative, but are we going to run out of food in Lake Superior, given the size of the Cisco year class? Is it going to impact other things?
Yeah, it's possible. In the past, when we have analyzed our zooplankton data from the early 1990s after the strong recruitment events in the late 1980s, we did see a decrease in the size structure of zooplankton, also a change in the composition of zooplankton. There were fewer large-bodied zooplankters like the daphnids and the limnocalanus around. So I expect that could very well happen. There were, again, a little bit anecdotal, but I keep my ear out. There was some sampling done on the North Shore, which is a standard midwater trawl survey, where they estimate abundance of herring for quota setting purposes. And the word I got is that the Cisco looked really good in terms of their sizes, and there hasn't been yet any evidence that they're growing slower. I think when we sampled the Kai during our bottom trawl survey in July offshore, that those fish had not grown really well. In my mind, they were a lot of 50, 60, 70 millimeter Kai, which I would expect to be larger as age ones than what they were. So I think that there may be a signal of some density dependent growth changes, at least in Kai, but not so far in Cisco, again, based on what my little elves are telling me out in the world.
Great. Thanks, Dan.
Yeah.
So we have
I didn't mean, that was a Game of Thrones reference, not to imply that my partners are my elves. I don't mean to. That was quite arrogant of me. Yeah.
Tom, Cornflow in the chat, noticing that smelt seemed down based on those CSMI slides. And he's wondering if the reduction in smelt also could have contributed to the year class.
Shoot, I don't know. Their numbers are down. That's for certain. But we kind of think about smelt as having maybe some localized impacts in some of the really high density areas. You think of like Black Bay, which used to have a huge commercial fishery that's, sort of has one still, but it's greatly diminished. There's some of the highest smelt densities in the lake. Maybe the fisheries and the abundances in the far western end of the lake in the Twin Ports is down. Whitefish Bay never really seemed to came back after the decline of Cisco's in the 60s. So I think it's like a localized effect. But I think, these larvae are present in the offshore surface waters. They're only interacting with smelt, not all of them at nighttime. So I just think that there's just not enough habitat overlap based on what we're learning about the distributions to explain or to attribute a decline to smelt. It's been up and down and all over the place, and smelt numbers haven't changed that radically, and yet we still see all this variation in recruitment levels. So, they get their share, don't get me wrong, they'll eat them, but I don't think it's a major driver. I think it's environmental factors and environmental forcing that's driving the recruitment variation. And then hope I'm right. That's what I just said.
Oh, that's good.
Yeah.
Another one from Scott Hansen about genetics.
Can we have another one from chat? Okay.
Yeah. No one from chat, and then we'll get back to you, Lars. What percentage are you batting, he says, in terms of being able to ID these young fish in the field? I don't know if he's talking about age zeros or age ones. And then he asks, have the genetic results helped or hindered your ability to confidently ID them in the field?
Oh, that's a great question. I think that we had some data from the first year of sampling. It would have been 29 sampling of the 28-year class. And I think we were about 90% on our identifications at that time frame. The age zeros weren't nearly as good. I don't know the exact percentage, but there was a lot of confusion where we attempted to call something a bloater and it came back a chi, and a chi that we identified came back a bloater, and that's because there was so much overlap in their sizes. But in general, by age one, I would say that we're about 90% or so. And most of the confusion in our field identifications are between bloater and chi, where we get something different than comes back at us. But I think it's been very helpful for us to have these genetic results in order to us to have at least a pretty good feeling that, we're at 90%, which, is good. And we have to decide moving forward a couple things, how much money we're going to devote at the center to the monitoring of this assignments of H1s, and also how we're going to fund it. Right now, it's all been funded through the template, your Coregonid template. And I'd like to see us move to more of a base managed or base funded approach to decide on how many we should do each year. I guess I tried on that answer, right? But I think it's helped us a lot to have confidence in our field identifications. Yeah.
You hit on everything he asked. And you said that you don't have this year's yearlings sent to Ann Arbor yet, but how many are you anticipating? Just curious what that effort will be.
We have, Bo, 2,500. I think there were maybe 1,800 from the spring cruise, and then another 500 from the offshore cruise. Okay. And that's going to cost us about $33,000. And we don't have the money right now because all of the work that did all of that cool research I just shared was based on reimbursable or, soft money. And so we're sitting on these samples, and I've been trying to beg my branch chief how to, give us some money to do it, but I haven't got it done yet. And I think it's really critical that we do, given, everything we learned about the 2022. To not get the genetic IDs on the age ones is a big mistake in my mind.
We just made that point again.
Yeah.
And I think he is on the webinar. So let's go to Lars.
So I was fascinated by this whole-scale change in species composition in the offshore of Lake Superior, where you have the Cisco all over the place in the early summer, and then it's suddenly just Kai left in the end. So I guess I don't really have a question, but it's a big lake, and they are swimming a big distance getting out and in. So were you surprised about that, I guess?
I was really surprised by that, Lars. Offshore zone was important to the larvae, like the Cisco. But then if you looked at some of the composition offshore, it's just like, where did they go? And so they're bigger, and maybe that's the time when they decide that they're going to migrate into the coastal regions. We know the coastal regions are very important to the juveniles. We have a lot of data that suggests that they're going to be fawned where bathymetric depths are less than 100 meters, and they're very rare in our past surveys at greater depths. So I think the migration happened in summer, maybe at least pretty rapidly after they got metamorphosized and they moved in. And I say that because I don't necessarily believe my hypothesis about disproportionate survival of Ciscos, because they were 88% of what we caught in the nearshore survey in the spring of 2023. And if we scale up the density estimates from our bottom trawl, and that comes with a wide range of assumptions, and I won't want to hang my professional hat on it, but we got over 2 billion age 1 Ciscos. So in the ballpark of what we got with the age 0 abundance estimate. So I think there was high survival, and I think that means that they made their way near shore, as soon as they could. Yeah.
So it makes sense, perhaps that they go near shore, higher productivity areas, warmer temperatures into the fall. But why do they go offshore in the first place?
I don't know. You have to look maybe in your backyard, because there was some cool work on NIDA that showed that, early on you catch the larvae Ciscos in really shallow waters, and then they up and leave the shallow zones there to occupy offshore depths, offshore waters.
But remember, Oneida Lake is the size of your little bay near shore.
Right, we have a difference in scale, but I think that there are some evidence of mass migrations of these Ciscos to more. We don't know why, but it must be important. To
Maybe
do it. Yeah. And maybe the age or the larvae Ciscos are getting swept out there. We do have a lot of currents, and there's surface-oriented fish, and who knows, right? I don't want to say that I know for sure why they're making those seemingly migrations, but it's more work could help us shed light on this. But we get what we get, and that's what it taught us.
Yeah. Thanks, Dan. Great working with you again.
Thank you.
I'm glad you raised the advection possibility. There's been a lot of work in Lake Michigan by Thomas Hook's lab, and Spencer Gardner is a PhD student, and we're thinking about, could advection from the nearshore spawning alewife and perch and them getting swept out through upwelling events out into the open waters, is it a good thing? Is it a bad thing? And how does that vary across years and with climate? And so when did Lake Superior stratify that year? I mean, its stratification seems to affect in Lake Michigan when advection of nearshore larvae occurs. Do you know if that was like July?
It was late. I mean, I think it would probably been the first or second week of August. Yeah. That's when we started. We wanted to start sooner, but we had a COVID outbreak. But anyways, when we started on the 18th, it was stratified. But I don't think, given what I've seen on the meteorological data, the surface temperature predictions, that it could have happened much before that. Yeah. Really late. But when it warmed up, it was cold, or it was still. for a couple of weeks there. We know because the sail drones won't move, and it warmed up rapidly.
And so those Cisco larvae were offshore before stratification then.
Yep, they would have been in July when it was still isothermic. Yeah.
Okay.
Yeah.
So less of a probability then of upwelling, shooting them off. Yeah.
Upwelling, yeah.
Okay, one from Nicole Berry. I don't know if you can see that in your chat. Great talk. I really enjoy the use of multiple sources of technology to try to understand the diel cycles and behaviors of these fish. Have you considered what abiotic factors could be influencing the depth occupied by the fish or mysis during the day and night? In particular, given Lake Superior's oligotrophic state, I'm interested in the potential for a UV avoidance behavior and wondering if you've considered that, if they're going deeper to avoid UV during the day.
No, I haven't. I've heard about this UV research, but I must say I haven't been tracking it closely enough to comment on intelligently. I think that, you know, we have pretty good understanding about the coupling of the mysid and chi migrations. Both seem to rise up to the top of the hypolimnion. Well, at least the chi do, and that they do overlap with mysids at night at those depths. You know, and the Cisco, for the most part, are going to be confined to the photic zone. We will catch them deeper, but mostly in the top 25 meters of water column where we have the highest zooplankton levels. Yeah, but I guess that's kind of one of the things that Cornell is very interested in pursuing right now with the sail drone data. And maybe Lars can weigh in, because we are seeing some pretty compelling evidence of fish tracking their prey in Lake Superior based on the day-night data that the sail drone was able to acquire. And since Lars is leading that, maybe he would care to comment for me and help me out here. Maybe Lars is left.
Yeah, it looks like Lars had to go.
Okay. Yeah, you know, they're working on a lot of things. One is looking at the fish and the mice migrations, and also being able to take the backscatter and tease out the two components there. What's the contribution of the backscatter from the fish and also the zooplankton? I think they're making good headway, as they've done kind of similar things in the past, but we'll learn more this winter as they have more time to continue to work on our data.
Okay. Yeah, good answer. Corey Goldsworthy.
Hey, Dan. Fantastic presentation as usual. I just want to, give a shout out to the USGS and Dan and the continued research that's going on for coregonids and Cisco in particular, with them being the most valuable and largest commercial fishery in our waters. The surveys that the USGS do on Lake Superior give us a rare, about 3-year heads up on additional adult biomass coming into our fishery, so we can help set expectations with commercial operators on increases or decreases in their quotas 3 years in advance. So that really helps. So I just wanted to give a shout out to Dan and the USGS and the continued research that's going on. As a management agency, it really does help what we do. So thank you.
You're welcome, Corey, and thank you for being such a strong supporter of our program. I appreciate that to no end. Let that be known.
Thank you, Corey. Very nice to hear. There's a comment in there from Kurt Newman. Dan,
yeah.
Read. It sounds
He's
like
probably gonna be mad at me because I'm talking about the age ones and getting funding for him. But go ahead.
No, he says genetic analysis is definitely something we need to get done. Several strategies to pursue, but he's supportive of pursuing every avenue for gaining this important information. Great job, and he's glad he was able to see your presentation, and he expected you to make that pitch, he says. So.
No surprise to him then.
Yeah.
Okay. Yeah. He I think he's at his deer camp getting it ready for relatives to come up. So yeah,
Ooh, wow, that's great that he was able to join them.
I don't know how, but he did.
That is his November trip.
Yeah.
Oh, I guess not. He says he wishes he was.
Ah,
Hey,
different
Renee,
plans.
I'm noticing, did you put the invitation to register or did you put the Zoom link in the chat?
It should be to register, but maybe it is just, I think join the, well, maybe. Let's get the actual to register.
Yeah, so while we still have a good number on, I'd like to encourage you to register for next month's webinar too. Other questions for Dan? Dan, I'll ask one more. I'm curious how you make those assignments, how you take that for the age zeros, how you go from the acoustic estimates and then the midwater trawl data and then make those assignments. And could that be explaining some of the shifts in species composition through time if the species are distributed not, exactly how you're sampling them?
Yeah, I'm sorry if I was unclear, but right now, what I reported and still the extent that we've taken it to is we're calling age zero Cisco's as a group in those acoustic densities right now, when we have not yet made an effort to take the genetic results and transfer it to the proportions of the different species caught at the sites to try to estimate the abundance of age zeros of the different species. I'm going to have to put my thinking cap on to get that done, and we just it hasn't been yet a priority, but by the time we publish, we should try. Yeah. So
the species composition you're showing
is a
like
current
different times. It's
Yeah.
just a random sample of fish that you're getting ID'd, and that's what you're showing.
Yeah.
Okay.
Yep. Yeah.
Okay.
Yeah. So it's random in that they were sorted and then they were sent in a subsample of at least 25 at every site, and then they were assigned. A few of the sites we did much larger subsampling because the question there is how many do we have to do at each site in order to kind of stop learning? Where do the proportions center as a function of how much sample size? And we did that during the age zero midwater trawl sampling, and like a half a dozen where we did up to 200. And then again in the springtime, we did the same thing with the age ones, because it's really critical to understand how many, if we have a big event, do we have to do at each site in order to understand the proportions and stop learning. If that makes sense.
Yeah.
Okay. So there's lots of things yet to do, Bo, with these data. It's we think it's the greatest data set ever, and we're working on it, and we'll continue to work on it. And you probably see us if we learn something new and important, sharing those in the future.
Well, thanks for sharing what you've already compiled so quickly so far. And I know that hopefully you're successful with getting more funding to do more things with this great opportunity.
Yeah. Thank you for the opportunity to share what we've been working on here at the station. And thanks to the audience for listening to us describe our results. I'm really grateful for the feedback we get. And if you have any more comments, don't hesitate to reach out to me and ask questions or share feedback. So thank you.
There's one quick comment before we go. Todd Williams asking for sort of a cross-lake speculation. I think he's seeing how you saw those Cisco larvae offshore, or even, of course, the adults, which we know are always offshore in Lake Superior. But he's saying he'd be interested to see if the Saginaw Bay Cisco stocking efforts follow the same offshore movement. He's recognizing it's still early, but do you have any sort of speculation in terms of where you might, if those Saginaw Bay Cisco will behave like your Lake Superior Cisco?
Shoot, I know what I've been watching. I know that there was a study, I think it was by one of our colleagues at Hammond Bay, where they implanted acoustic tags in some some newly stocked fish to understand their behavior. And I know that, I think it was last year, I've seen a talk where they came back and they caught them in gill nets, which was somewhat of a surprise because our efforts to try to sample fish with some of the bottom trawl surveys we added, I didn't think had been overly successful to date. But yet, what did they catch? I think almost 50 adult Cisco came back to Saginaw Bay, which is like wonderful, wonderful news. And I think there was even some evidence based on OTC, if I'm remembering the talk right, at the Coregonid symposium, where one of those fish, or maybe two, was thought to be a wild fish, while the rest were marked with OTC, so they'd been a hatchery release. But yeah, you know, our Cisco, I think, are kind of a different beast. Every time we do a cross-lake comparison study of Cisco's, we find that Cisco and Superior do different things. They have smaller eggs. Their eggs seem to overwinter in deeper, sandier bottoms. And we're catching them offshore because there's enough of them to know that the adults utilize offshore waters. Not all of them. They'll be pretty much over the entire surface area, but you just don't see that in the Michigan and Huron midwater trawling effort. They're mostly limited to like close to Grand Traverse Bay, I think, in Michigan, and maybe North Channel and Lake Huron. So I don't know if that's because there's just far fewer of them, or if our fish are just really much more pelagic. So yeah. I probably fumbled that question, but I shouldn't talk about maybe some of the behaviors in lakes that I don't actively work on. So, yeah.
Yeah, I think from what I know, you captured the acoustic movement data from Todd Hayden and
Todd
Brook pretty well. I mean, they've seen them up in the Lake Chanot region, staying relatively near shore, but also moving offshore. And then, when they did tag small hatchery planted stocked fish, they lost them pretty quickly. And there's now going to be a more intensive array to try to see where they go when they're stocked as small fish. And you're right, they are coming back. Really encouraging news for the adults to come back that were stocked, several years ago. So 4 or 5 years ago.
You're the czar. You have to keep track of it all, Bo. I don't envy you sometimes. All the different research that's going on. It's a lot to take in.
We're not going to let you go yet. There are questions again.
Okay, that's fine.
This is from Matt Herbert. And did
My
you say
friend
something about greater Chinook growth, Dan?
Yeah, is Corey on the line still? Or is he
Yep,
gone
I'm
now?
still here.
Maybe Corey said that. Okay.
No. I heard Corey say something about
Yeah.
Maybe you can answer Matt's question for me, please, and then it comes from you.
Yeah, sure. After the initial thought that there might be a 2022 year class coming through early this spring, April 2023, we first saw at our Knife River steelhead trap, we first saw steelhead approaching and exceeding 30 inches and 10 pounds in bigger numbers than we ever had in the past. And that was kind of our first hint that, hey, something might have went on. And then as the season progressed, the reports that we're getting from charter captains and anglers is that, they're seeing a lot of fish that are bigger than usual. And this was fairly early in the year. And then by August, September, there were definitely coho salmon were the big winner this summer. Set a new Minnesota state record for coho. It works out well because we did a CSMI lake-wide diet study in 2021. And the non-native salmonids, particularly Chinook salmon on the North Shore of Minnesota, were eating primarily terrestrial insects in 2021. So, from one extreme, very food limited in 2021 to here we are in 2023. Everybody's got the feed bag on. Lake trout, Chinooks, cohos, pinks. Everybody's taking advantage of, the edible sized Cisco that have been out there now for a year and a half. However, I've been the downer already for some of our anglers and charter captains, saying, you know, these things grow fast, and they're fairly soon going to exceed the gape limitation for the majority of non-native salmonids out there. You know, once they hit the adult size, 15, 16 inches, they'll probably still get eaten by the largest lake trout that's out there. But, you know, it kind of reinforces, from a management perspective, what we've been telling anglers on Lake Superior is that just by us stocking more Chinooks doesn't mean you're going to get more or larger Chinooks, particularly with that 2021 lake-wide data set. You know, if Chinook salmon in Minnesota waters are eating terrestrial insects, stocking more Chinook salmon is not going to create more or bigger Chinook salmon. So it's kind of good to see the support of kind of what we've thought has been going on in relation to stocking non-native salmonids and lake trout restoration, and, you know, Cisco restoration through time as well. So yeah, we're definitely seeing that response from predators.
Thanks, Corey. Sorry, it was coho, not Chinook. I might have misspoke earlier.
That's really interesting. I hadn't heard that. Yeah, thanks for sharing that, Corey. Good question, Matt. All right, last question. Anybody have a dying question out there? If not, have a great weekend, and we hope to see you in about a month. Thanks again, Dan, for doing this.
You're very welcome, Bo. It's my pleasure.
Great job, Dan.
Thank you.